Thank you very much, Hans. I hope you can hear me. Good afternoon also from my side. I'm Johannes Thema, working at the Wuppertal Institute for Climate, Environment and Energy in the city of Wuppertal in Western Germany. Together with me is always also my colleague Felix Surkemper. He is based in Berlin, but I will do the entire presentation, so you will hear me speaking. Felix will be there for question and answers after the presentation. Yeah, I'm happy to present you today first insights and an overview of the COMBI project that we executed over the last years. This was a EU project dealing with multiple impacts of energy efficiency. This is a topic that has been around for decades, probably under many kinds of different names. So you might know terms like multiple impacts, multiple benefits, side impacts, co-impacts. There are a number of other terms around. I will not dive into the discussion of these concepts, but we decided in the end to go for the term of multiple impacts, because impacts of energy efficiency are probably in most cases positive, but there may also be some negative impacts. So this as a short forward. What expects you now today in this presentation? We will give you an overview of the project and key results, and in the second part I will give you a live demonstration of the online tool that has been developed in the frame of the COMBI project. In the first part we will talk shortly about the project background objectives, also the structure of the project, how the steps we took for arriving at the final results. And this involves a few different steps. This was in the first place the development of common input data that was used for the whole modeling exercise, and the scenarios that we used in COMBI and that result from these energy efficiency actions. Then I will talk shortly about the different models that we applied for estimating the different impacts and some key results. Finally, a few words on key conclusions that we draw from the outcomes of the project, and some caveats and further research needs. Okay, so let's directly dive into the presentation. The short background is, yeah, as already said, the project was funded by the EU Horizon 2020 program and ran a little more than 3 years until summer of this year. It was funded with €1 million, and it was in total 5 project partners coordinated by Wuppertal Institute and including University of Manchester, Advanced Buildings and Urban Design based in Budapest, Copenhagen Economics and University of Antwerp. And all those partners covered different parts of the impacts. The main targets of the project were to quantify and monetize as many as possible of the multiple impacts of energy efficiency for the whole EU, but not only on a EU level, but also on a member state level, and for each of the different energy efficiency improvement actions as we define them. Maybe short word on the term of energy efficiency improvements. Other may call it measures. We decided in the end not to use the term measure because this may be confounded with policy measures, so we rather draw on the term of energy efficiency improvement actions, which is the term also used in the Energy Efficiency Directive. We wanted to do this in a common framework, so there is a lot of studies on different multiple impacts of energy efficiency around, but many of them focus only on one specific impact or cover only one specific sector or one kind of improvement action. So what we wanted to do is to do as encompassing as possible study for the whole of Europe. And as a second point was then to not only quantify those impacts, but to integrate this into what is commonly called cost-benefit analysis, and which commonly only includes investment costs and energy cost savings. So we also wanted to include those multiple impacts into an extended cost-benefit analysis. So that were the main targets. A few words on the kinds of impacts that we cover in the project. we decided to frame it into kind of 5 major categories of impacts. Air pollution, which has sub-impacts. It's on the first hand direct air pollutants, and resulting from this actual air pollution impacts on human health and ecosystems. Then different kinds of resource impacts, different kinds of social impacts that include disposable income, but also different kinds of health impacts that are related to social issues, and also labor productivity. Then we have a number of macroeconomic impacts estimated, which include employment, GDP, public budget, but also prices, not only of fuels, but also ETS prices, in terms of trade effects. And then we have the 5th category of energy system impacts that cover, on the one side, energy system impacts, and on the other side, energy security impacts, and we have a number of different indicators estimated here. A few words on the structure of the project. As already said, we wanted to build all these impact quantifications on one common database. So what the first task was is to come up with a consistent data set of energy savings and additional energy cost savings that would then be used as inputs for the further impact quantifications. And from this, we also were able to generate entire scenarios until the year 2030 in Europe for all the different EU member states, and by individual energy efficiency improvement actions. On all those steps, I will tell a little more in just one second. Those input data were then used for actually modeling the individual impacts by applying different kinds of models. A little more on this as well in a minute. And then the outcomes of all these impact modeling were fed into a common database jointly with the input data that we generated. And this common database is then exploited by the COMBI online tool and makes all the different impacts accessible, available, and visualizes them. And the user accessing this online tool can also configure the different graphical outputs and cost-benefit analyses. Of course, all this is also documented, and you will find all the detailed information on the website. I think a link to the website is on the very first slide. So this includes information on the different energy efficiency improvement actions of the input data and the scenarios that we constructed, then literature reviews on the different models, and also a very detailed documentation of how the actual modeling and quantifications went about, together with also a summary of all this, which is the quantification report D2.7 very below. Also for the tool, we have a document. It's a tool manual and also a documentation of how the tool actually works and the technical specifications. And also you will find a policy report that draws the main conclusions from the overall findings, and a very brief summary brochure of the project which summarizes the whole project on a mere 4 slides. Okay, so just a little more on the input data. As you can see in the table, we covered 3 sectors, mainly buildings, transport, and industry. And within those sectors, we cover a range of different individual energy efficiency improvement actions. So it's in total 21 actions that we cover. And out of these actions, we have energy savings, energy cost savings, but also the investment costs needed to realize those savings. Now, how does this relate to the existing European models? We always try to streamline the COMBI modeling with the official EU primes scenarios that are used for the EED impact assessments. But it was not entirely possible to match those, because from the prime scenarios we do not have a lot of very detailed information. We have the macro indicators outputs, but not really all the underlying assumptions and stock model assumptions and so on. So what COMBI did is for all those actions listed here, which I will not go into detail, we applied stock modeling, and with the stock modeling we came up with scenarios that we tried then to streamline also with the prime scenarios. What has to be said is that COMBI does not cover the entire energy system, so we do not cover the agricultural sector. That was not possible. And also in the sectors that we cover, there are a lot of other additional possible energy actions, energy saving actions, that we do not cover, but we tried to select the most relevant ones. And also the energy supply sector is not covered by COMBI because the focus was on energy end-use savings. The data that we used draws as far as possible on official Eurostat statistics and other EU statistics, but also on additional dedicated EU projects that came up and published more detailed data that we had to use for quantifying those impacts. So what is the outcome of our modeling? Maybe just a few words on the official scenarios that are out there. As you probably know, the latest scenarios that were published are with the EU EED impact assessment in 2016. So this is the dashed black line. Here we have a baseline scenario from the year 2016. That's the latest baseline that we have available. The dark black line above is the Prime's 2007 baseline scenario. So we see that the 2016 baseline is already very much adjusted to a different reality than what has been thought in 2007. But still, when at EU level, policy or politicians are discussing about energy saving targets, those targets relate to the 2007 baseline. So this probably most of you know. If a target of 27% reduction is discussed, this relates to 2007 and not to 2016. That's a very important point. And it also means that a 35% target is not actually 35% savings versus the current baseline, but versus 2007. Now, how does COMBI relate to this? We see that we have differences both in the starting year of our modeling exercise in 2015, but also in the final end year of 2030. In the start year, we are starting from a lower level. This is due to more recent statistics that are being used in COMBI, so we tried to fit our scenarios to actual reality in 2015. But then we also see that our baseline is going slightly up while the EU baseline is going slightly down. An explanation for this is a little difficult to find. We can try to explain, but because Primes does not really publish all the underlying data, it's hard to see where those deviations actually come from. What we did in COMBI is we did a real bottom-up modeling for all those different sectors, all the different technologies, and applied reasonable assumptions on how both efficiency technologies change, how penetration rates may change in a baseline scenario. And this baseline or reference scenario also includes existing policies. So for example, we assume that from 2020 onwards we will only have nearly zero energy buildings for new buildings. So all these kind of political standards are already included in our baseline, and still our baseline goes up. Then the COMBI efficiency scenario that results from all the additional actions that we might implement is very comparable to the UCO 30 scenario, meaning a 30% energy saving target. But if you look at the savings, at the spread between the reference and the efficiency scenario, the COMBI scenario is more comparable rather to the 33% energy savings target. Oh, geez, just a few words. Yeah, and what we now did in the project is we took the energy savings, the investment costs, and from these inputs try to estimate the multiple impacts in the year 2030. These input data was then used to model the different impacts. And here we applied a number of different models. For air pollution impacts, we applied the Gaines model, which is probably the most up-to-date and most detailed model for modeling air pollution, and which at once also gives effects on ecosystems and human health. For resource impacts, we applied here in Wuppertal Institute life cycle modeling. The social welfare impacts were modeled with dedicated newly built up models. And economic impacts we divided in short-term impacts and long-term impacts. So for the short-term impacts, Copenhagen economics applied an input-output model, and for the long-term impacts, a CGE model. Energy system impacts were also modeled with a dedicated, newly set up COMBI energy balance model in the LEAP tool. All these impacts that were then modeled were, as said, fed into the COMBI online tool. So we will in a moment have a look at the tool itself, how it looks, how it works. But some key results to present you just beforehand. For air pollution, we have very large impacts. So this was already expected, but it goes into millions and even billions. And for resource impacts, we have no monetary impacts, but only physically estimated impacts. Social welfare, here the impacts depend very much on whether we assume that policy is targeting energy vulnerable households. So here we estimated a range of impacts depending on how policy is actually implemented. Productivity is also a very significant impact, labor productivity. And economic impacts are also very large, so this was already expected, but here we have to say that it's a difficult field estimating economic impacts, especially the short-term impacts, because input-output modeling results generate impacts that are or that can be actually realized only in a situation where economy still can expand. So in a phase of economic boom, it might be that these impacts are not actually realized, but rather leading to a crowding out. So this is an impact that always has to be seen in the specific context. Energy system impacts and energy security impacts are also among the larger ones, which also go into billions. If we sum up all those impacts, which is of course only possible for those that can be monetized, because we cannot sum up different physical units, this also gives an interesting picture. So this is what is actually needed if we want to do any kind of cost-benefit analysis. However, COMBI tried to estimate both. In the first step, the physical impacts, and in the second step, the monetary impacts. And not all of those that have been possible to quantify in physical terms, not all of those were also possible to monetize. So in the cost-benefit analysis, we actually have a number of impacts that are not represented. But those that are represented, if we sum those up, this gives a picture like this. On the left side, you see all COMBI energy efficiency improvement actions, and you see that a cost-benefit analysis is already positive if only doing it the standard way, but if we sum up the multiple impacts on top, it changes dramatically the estimation of net impacts. And then, as said, the economic impacts are somewhat difficult to estimate whether they will be actually realized or not, so this is why we put them next to the impacts. But you see that in terms of size, they are potentially very large. If we look at only residential buildings on the right side, the picture is even more dramatic. multiple impacts in relation to energy cost savings are even larger, so it's almost doubling the net benefit side. And the economic impacts are even larger in relation. So this is due to labor intensity in the building sector. A few policy recommendations that we draw from our work done here over the past years, that energy efficiency, is not only a case for greenhouse gas mitigation, but it has a number of other different impacts, and it's really key for policymakers to consider all those different impacts. Cost effectiveness of actions improves substantially if you include those impacts into your evaluation. And it's important to have really reliable quantifications that can support policymakers in selecting instruments and policies that really maximize social welfare. So the problem is that if you do not look at all those multiple impacts, it actually may lead to an underinvestment in energy efficiency. And another point is that because those impacts are really multiple, and multiple also in terms of policy arena, policy fields, they actually concern different kinds of policy departments. So what would be really needed is involving all kinds of different policy departments to generate a cross-sectional cooperation, which is of course a very hard task to do. We have a number of future research needs and caveats that we also have in the project. So first of all, as already said, we do not have a full sectoral coverage and also not all efficiency actions covered. So this could be extended. Then there is still a number of impacts that cannot and could not in COMBI be estimated. Then another challenge is that technologies are continuously evolving and policies also, so you actually would need to adapt and to adjust your modelings all the time. And another point is impact values that we now estimated for the COMBI scenarios are actually non-linear because they're dependent on the level of impacts as they are already there in the specific national context, and also dependent on the specific impacts. So it's not easy to derive some kind of general factors like 1 kilowatt hour of energy savings will lead to this and that much of this or that impact, because it depends very much on the specific context. In general, there is a lot more data and research needed on the issue, and then related to the summing up of different impacts, the aggregation or synthesis of all this, there's also a lot of work to still be done. One is that impacts may overlap, so you need to be very careful not to do a double counting of impacts. In COMBI, we address this by simply excluding any kinds of impacts where we fear there might be double counting. So this is why we, for example, not included GDP impacts in our common cost-benefit analysis, because GDP might be double counting with many of the other impacts. But then this kind of proceeding may underestimate the total impact. So there is still work to be done on this. And then we have a number of non-monetary impacts which are very difficult to monetize or contested to monetize or maybe not even possible. So we need to find ways of how to include those into the argument as well. I will now directly dive into the presentation of the online tool, because there is not much time left. I hope you can see my screen now. So here you have a view of the COMBI website. The URL is combi-project.eu. You also have a first intro video to the case of multiple impacts, why they're important, and so on. You have all the project reports previously mentioned under the download section, And now we directly go to the online tool. You have a few information on the general background and also on the different features the tool offers here below on the page. But I will not do this now, but directly launch the tool. Here we have one issue, because imagine we have more than 32 impacts in the tool. We have 28 EU countries and many other different values that need to be loaded. So loading of the tool sometimes takes a few minutes, but seconds. So this is the basic view of our tool. The tool serves mainly for two purposes. It's first of all accessing and browsing the impacts that we quantified in physical terms, as you see here above. I don't know if you can see my mouse, I hope. And then in a second step, in monetary terms for those impacts where monetization was possible. And in a third step, it's possible to analyze this in a cost-benefit analysis. So let's first have a look at the physical terms. Maybe another few words. On the left upper side, you have a few configuration options for the graph, and on the lower side also, here you can customize how you want your axis to be viewed. So for example, we now have energy savings by country, but if I want to display it by action, I just click on action and you now have the energy savings sorted by the different energy efficiency improvement actions. Most importantly, we have two different modes. We have a standard mode of the tool and an expert mode. The standard mode basically summarizes many of the impacts and also limits the kind of options you have for displaying to not overwhelm newcomers to the issue. I would rather now go to the expert mode, because this has the full list of individual impacts that we quantified and also has the full range of displaying options. Now come on. So here we have the main menus where you can select what actually to be displayed. So we're now looking at energy savings, but we could also look at any kind of other impact. Let us say GDP impacts. So in that case, it's now GDP displayed by, so increase of GDP that may be achieved by implementing those energy improvement actions. And because this is now the physical impacts, and most of the physical impacts come in different units, it's not possible to sum up different units in this physical mode. This is possible in the monetary mode. So if we go to the monetary mode, then you can select multiple of the impacts and they're stacked up on top of each other. But obviously this is possible only for those impacts that can be monetized. So now in the menu you will see that we have some which are light gray. Those are the impacts that are not monetized. Only the dark gray ones can be monetized. For the selection menu, you also can select the countries that you want to look at. So it may be only one country or two countries or the total EU. And in the action menu, you can look, for example, at only one sector or at all sectors or only one action and so on. So you can customize what you're actually interested in. Also, the outputs in the graph can be displayed in total figures, or they can be relative to GDP, 2015 GDP, or per capita of the country. So if you're interested in country comparisons, it's probably rather useful to have it per GDP or per capita, so this can be directly done here in the tool. Then if you have found some kind of graph that is interesting for you, that you want to share with someone else, you can just click on the Share Graph button, and this will copy the link to this graph, to this output, into your RAM, and you can just, with Control insert it to wherever, email or whatever. Also below the graph you always have a legend, and a possibility for a data export as an Excel file, or you may print the graph. Now, if we go to the cost-benefit analysis, again, the tool needs to load all the data in the background. Be aware it's a lot of data. It's around 5 megabytes that need to be loaded, so this takes a short time. I will first start with a very traditional cost-benefit analysis. So this is now only including, as you've seen, this is now only including energy cost savings into the cost-benefit analysis. These are now total net values per energy efficiency action, but I can also disaggregate this into the different impacts. So you now see in the gray bar the investment costs, annualized investment costs, and the blue bar are energy cost savings, annual energy cost savings. The red bar is the net value annually per energy cost saving, per energy efficiency action. So what we can now do with the COMBI outputs is we can include all the different monetized impacts into these kind of cost-benefit analysis, and this obviously changes the picture. We now see that those impacts that can actually additionally be stacked on top now change the net values. And those outputs can also be displayed in different kinds of versions. We, for example, can levelize these cost-benefit analyses. So this basically means division of the values by either energy savings or greenhouse gas emissions. So this is now levelized by energy savings of the different actions. And if we use, in addition to these levelized costs, information on the total potential of energy savings or greenhouse gas emission savings, we can construct marginal cost curves from that. So this is also possible with the tool. Here you see the marginal cost curves, including marginal cost curve of energy saving. You also can do it by greenhouse gas emission savings. So this is including all the impacts, and you see that compared to a situation where we only include energy cost savings, so you now see how the curve changes, it shifts upwards. This is basically the important story of this project. So we see that all efficiency actions are more costly if we exclude all the multiple impacts, and if we include them, the cost curve shifts downwards. This is probably the important story and the output, and also the end of my presentation. So I would give back the microphone to Hans for managing